So hi friends, greetings of the day. So now we are going to see answer for that. There were I have posted some few quiz questions in four different presentations. So today now we are going to see for part one answer. Okay, for part one, the antennas and RF concepts question part one. Now we are going to see the answer. Okay. The first question was highly directive or high gain antennas has. So highly directive means what? It is more of most of the power are highly concentrated towards particular direction. That is highly directive, which is why we call it as high gain antenna. Okay, has it should be narrow beam width, which means for highly directive means so most of the energy is focused only only particular direction. That's why narrow beam width and large coverage range, not area. Please remember large coverage range. So these two are the answer. So that's why the answer is D. Okay. So it will not have wider beam width. So large coverage range. Okay. Range means range of distance covered by this high gain antennas or highly directive antenna will be more. Okay. The next question and the next answer is advantages of decibel is the first straightforward advantage is that compression of data, because for example 1 into for example 10 into 10 power 7, if you want to write as a digit, it will be very huge number. So then if you mention in the dB, it will be 10 power 7, 10 into 10 power 7, which means so 10 power 7, for example 10 power 7 will be 70 dB. That's it. So you are compressing the data, okay, using to represent ratio or non-unit parameters. So because it is used to represent, so wherever we find ratio, okay, for example gain, so these are all the non-unit parameters. So in that case we can use this dB. We can use this dB or dB in the form of for example gain can be represented as dBi, dBd, and many other parameters are there. Amplifier gain. So many parameters are there. So those parameters can be represented using this decibel. Next question is, see, what is the value of 23 dB plus 200 in dB? So here the critical point is that, see, you should convert 23 dB to 23 dB to absolute value. So it will be 200. Okay. So then what you will do, 200 plus 200, it will be 400. Okay. Then answer is 26 dB. So I think you can relate this. See, 23 dB plus 200, which means the absolute values are getting doubled, but the dB, the difference is only 3 dB. So that's why we call it as half hour beam width and all. It is half hour means the 3 dB beam width. Half hour beam width is also called as 3 dB beam width. So because whenever the absolute value gets doubled, in dB it will be plus 3. That's it. So that's why 23 dB plus 3, which is 26 dB. So again we repeat. So what you have to do is you have to convert the dB to the absolute value. Then you have to add this absolute to both absolute values and then calculate the dB value. Okay, that's how it should be. Why beam forming require in especially microwave communication? Because there are multiple reasons, out of which to avoid few are two are to avoid or reduce multipath fading. Because if you do not have beam forming, then for example if a person behind the building, so you cannot cover them, because it is more prone to multipath fading, because high loss. Okay, because path loss is directly proportional to the frequency. Next is highly directive beams, hence less power consumption by UE, because your beam is focusing towards UE, wherever he is. He can be nearby cell tower or edge of the cell tower. So the power that received power will be almost same. Okay, not like cell coverage. The person who is near to the tower, he will get a very good signal. When he moves out near the edge of the signal, he will get a very poor signal. But that is not the case here. Okay, that's why the answer is A and B. So large cell coverage area will not come, because it's not a cell coverage, it's a beam coverage. Okay, so the answer is D, which is A and B. Next is massive MIMO array used in millimeter wave communication for what? So in the first one is straightforward thing is a beam forming. So that's now we discussed. Next is diversity. So to enhance the throughput, or to enhance the enhance the SNR, or to avoid, in other words, it is to minimize the blur, okay, or blur, okay, bitter rate. Next is high throughput, okay. So these are all the three answers. Last is different types of antennas. So next question, answer for this next question is that different types of antennas. So as we mentioned, wire antennas, reflector and lens antennas, printer antennas, antennas. So that is the answer, because dipole antennas will not come, because dipole is a wire antenna. So thank you all, thank you for watching. Please do subscribe for future videos. Thank you.